A workstation makes one DNS request every 5 minutes. All day, all night. The domain looks harmless, but the left side of the query is a wall of random letters and numbers. No web proxy alert. No firewall block. Nothing screams malware. Then the SIEM lines up the resolver logs and the pattern is obvious. Same client. Same interval. Same strange naming style. That is the value of DNS tunneling detection. DNS is noisy, but bad DNS has habits. DNS tunneling detection is SIEM monitoring that looks for DNS behavior that does not match normal name resolution. A beginner can say it this way. We collect DNS resolver logs, compare each client against normal DNS use, and alert when the queries look like hidden communication, automated callbacks, or data leaving in small pieces. In NIST style terms, this supports detect and analyze. It does not magically prove intent from one packet. It gives the SOC evidence: which host asked, which domain was queried, what record type was used, how often it happened, and whether that pattern is rare for the environment. Before DNS logs land in the SIEM, defenders usually see fragments. The firewall sees outbound DNS as allowed traffic. The endpoint may log process details, but only if the agent is healthy and the event is retained. The DNS server sees every lookup, but that data often sits in flat files nobody searches until after an incident. That gap matters because DNS is almost always permitted. Attack callbacks, DGA-style lookups, and slow data movement can hide inside routine resolution. The SIEM fixes the visibility problem. It centralizes resolver events, preserves history, enriches domains, and lets analysts ask pattern questions across thousands of clients at once. The mechanics are simple, but the details matter. First, log at the resolver, not the endpoint. The resolver gives the clean network truth: client IP, queried name, record type, response code, answer, and timestamp. Second, normalize those fields in the SIEM so every query is searchable. Third, baseline query volume per client. A developer build server, a domain controller, and a finance laptop should not be judged the same way. Fourth, create detections for specific giveaways. Long high-entropy subdomains stand out. DGA-like includes consonant-heavy strings, many failed lookups, and newly registered domains. TXT and NULL record spikes are suspect because they are uncommon for many user workstations. Fifth, alert only when multiple signals agree. Here is a generic SOC story. A SIEM rule fires for a workstation with an unusual TXT record count. The analyst opens the timeline and sees requests every 3 minutes, almost perfectly spaced. The domain is new, and the subdomains are long strings with high entropy. Not one query is enough. Together they tell a story. The analyst pivots by client IP and finds the same host is the only one asking for that domain. Baseline data shows this user normally makes a few hundred DNS queries per day, not thousands. The team checks EDR for the host, confirms an unusual process made network requests near the same times, isolates the device, and blocks the domain at DNS control points. The strength of SIEM-based DNS tunneling detection is pattern recognition at scale. It sees timing, volume, rarity, record type, and domain history across the whole organization. It also keeps the evidence trail analysts need for incident response. The limits are real. DNS alone does not identify the person behind activity. It may not show the original process unless you join it with endpoint telemetry. False positives happen, especially with security tools, telemetry agents, developer services, and content platforms that use complex hostnames. Encrypted DNS can reduce resolver visibility if clients bypass approved resolvers. That is why policy, network controls, and logging architecture matter. This detection sits in the middle of the defensive stack. DNS controls can block known bad domains and enforce resolver use. The SIEM correlates DNS logs with firewall, proxy, identity, VPN, and endpoint events. EDR explains what was running on the host. UEBA can help with per-client baselines, such as a laptop suddenly behaving like an automated resolver. Threat intelligence adds domain age, reputation, and registration clues, but it should not replace behavior. For incident response, the SIEM becomes the timeline engine. It answers when the first query happened, how often it repeated, whether other clients joined, and what changed after containment. Start with coverage. Send recursive resolver logs to the SIEM. Do not rely on endpoint DNS logs as the primary source. Normalize timestamp, client IP, user if available, query name, record type, response code, answer, and resolver. Then build 5 starter searches. 1. Top clients by DNS query volume against their own baseline. 2. Longest subdomains by client. 3. Highest entropy labels. 4. TXT and NULL record volume by client and domain. 5. Repeated queries at steady intervals grouped by client and domain. Learn basic statistics, string handling, regular expressions, and time series searches. Review alerts weekly, and document known good noisy systems. Recap in 3 beats. First, DNS tunneling detection works because strange DNS behavior leaves patterns, long high-entropy subdomains, DGA-like names, TXT or NULL spikes, and steady timing. Second, your SIEM is the right place to compare those patterns across clients, domains, and days of history. Third, log at the resolver first, then enrich with endpoint, identity, firewall, and UEBA context. Do not chase every weird domain. Build detections that combine signals and match your environment. If this was useful, subscribe. New Security Tools Decoded episodes published daily, along with the daily ranked CVE brief on this channel.